Good morning, guys. Uh, I've already sent the YouTube link for those that will be joining on that wants to join on YouTube. And without wasting time, I think I will just continue from where I stopped. Please, there are many. There are. I can see many hands up. Please put down your hands. I don't. We don't need any distraction. We don't have time. Just allow the lecturer to do the work the way uh, we know how to do the work, please. So please put down your hand. I can see Samuel wrote where I've sent and the lecture is about to start. So put down your hands. There are a lot of distractions. Thank you. We don't want distractions. Just let us do what we because after today now, another lecturer will come on Monday. And so we don't have much time than to work together. The only thing I want to hear from you is can you see my voice? If you can see my voice, then we are fine. That's the most important thing. And I'm also sure I'm live on YouTube. Uh I will just I don't want to go because some of you complained when I asked you to give feedback that there are a lot of repetition in the lectures. It was done just to take care of some of the things that we did not do in the first lecture. That was why I decided to repeat some of those things. So, uh, I'm very sure you know how liquids, solids, and gases, how they are arranged. You know that liquids have indefinite shape and they have definite volume. That's why if you put them in any container, they are able to take the shape of the container, but they don't have definite shape because the arrangement of the molecules are not as fixed as you have in solids. Uh, uh, oh, sorry, I want to use this. Can I use this? Please confirm. Can you see this now? I've decided to use. I'm going to use my pen to see if you can Yeah. Good morning, guys. Technology. Technology. Technology problem. I was logged out, maybe because as a result of poor internet. And when I tried to log in back, I was told there is no chance for me to come in. I don't know. I don't know. I don't know. Like I should be able to do something to this. I don't know. I don't know. Sorry, guys. Apology for that short in transmission. Is as a result of problems. Let me see if I'm still on YouTube. Okay, so we are still on YouTube. So sorry about that. And as a result of this problem, I will just need to rush and discuss. I believe you can see the screen. Without wasting time, we know you know this from your elementary, from your secondary school, that matter is, we have three states of matter: solid, liquid, and gas. And you know the arrangement of uh, the molecules. Because gases are randomly packed, they have no indefinite shape and they don't have indefinite volume. Consequently, you can arrange them easily. They fit into any container that you put them. So all these are information that you know very well. Can you see the screen? Adeni Christiana, can you see the screen? I just want yes, yes. Just type yes and I know you. Yes, thank you. So I don't think all these are what you know already. This side is looking at change of state, where you have water changing state to solid, liquid, and gas. And so by the time you look at what you have on the slide, I'm very sure you're not going to have any problem. All the plans for today has been affected. So changing states always require energy in form of heat or a change in pressure. And so you can see when you have a gas, you compress it, it's going to turn to liquid. You have a liquid, you compress it, it's going to turn to solid. And it can also go the other way around. When you heat your solid turn to liquid, and when you heat your liquid, it turn to gas. And you must note that when substances or matter changes state, it does not change its composition. When it changes state and it does not change its composition, then you refer to it as physical change. For example, water. When you freeze your water, you have ice block. Freezing, all cases of freezing is physical change from your elementary school. I'm very sure you know that. So it's not, if I decide to cut a wood into pieces, I've only cut that wood into smaller pieces, but it's still going to remain wood. So nothing has changed in terms of chemical composition. Consequently, it's a physical change. So all I'm saying in essence here is that you know already that we have two types of changes. You have physical change and chemical change. And so for physical changes, there is no chemical composition. The only thing that has changed is the physical appearance. And that's why your solid ice block will remain the freezing of water to ice block is a physical change, because the only thing that has changed is just the physical appearance. The properties of the substance is still the same. So all cases from your elementary, they will tell you all cases of melting and boiling are physical change. Their chemical composition has not changed. Oh, this is not the one I want to use. Align. New share. Sorry about that. I okay. I added few things last night while I was going through it. But I think we can continue so that I don't know what is happening today. All attempts Guys, let me just apologize. I'm not happy with what is happening today, but I can't help it. That's the problem of the country now. I don't know. I don't know. I don't know. All attempts to so characteristics of physical changes, melting point. All this will come under all cases of melting, all cases of boiling point, vapor pressure, color density. Nothing has changed here. So all of them will come under uh, physical changes. Thermal conductivities, all these are, if you have anything that has to do with just melting point, changing of melting point, or if you see any change in boiling point, then you are just talking about physical change, color density, and the rest of them. A chemical change, you know this already from your elementary school. When a substance changes into something new, it is when matter undergoes changes in composition. For instance, if I look at sodium chloride, if I dissolve this in water, H2O, it's physical because nothing will change. Water will just dissolve it, and nothing has changed yet. But if I combine sodium with chlorine, new something will be formed, and that's sodium chloride. Then this is chemical change. So for chemical changes, there's always changes in composition. That's just what we want you to know there. There is changes in composition, and you can easily observe it. If you add, for instance, calcium carbonate, you heat it, new things will be formed because you'll be able to see that you're going to get calcium oxide plus CO2. So new substances are formed. So please note all this. This you know already from your elementary school. So I don't think um, so all cases of burning from your elementary school, you know, they always tell you that all cases of burning, combustion, reaction of an acid with a base, all will give new substances. So consequently, there are chemical changes. So some of the activities that will result in chemical changes, reaction of a base with an acid, reaction with oxygen, all cases of combustion, oxidizing agents, ability to act as oxidizing agent, ability to act as reducing agent, all are examples. Note that the exam we are going to give you, we're going to put some of these things. The questions are not going to come direct. It can just be a question of reaction. So that will test your knowledge of understanding of some of these things. So some of them will not come as direct at you. You are seeing them now. Corrosion, is a chemical change. Then we also have what we refer to as intensive and extensive properties. Properties that depends on the amount of substance and substances that I'm going to send the slides to you. So when you check the notes, some of the things you're going to see are intensive and extensive properties of matter. So I want you to look at, you will see that, and I'm very sure by the time you read it, you're going to understand them. And I think you're also going to see in the notes, you'll be able to compare physical and chemical properties. Then substances. What is a substance? This you know from your elementary chemistry, that you can classify substances into element, compound, or mixture. So this slide will give that detailed information about how to classify them. And you know when you have your mixture, you know you can always differentiate mixtures from pure substances. For instance, you know mixtures always have variable composition. That's why if you have salad, I prepare my salad and you prepare your salad, the composition will not be the same because mixtures don't always have variable composition. But pure substances, like compounds and elements, they have fixed composition. That's why the formula of water will always be H2O. So you're going to see in that and some of the characteristics of pure substances. You're also going to see some of the characteristics of pure mixtures. Some of the characteristics of pure mixtures you're going to see. So all these you know from your elementary school. These are all. Then you can have homogeneous mixture and heterogeneous mixture. And how do we separate them? These are some of the things that you need to find out yourself based on the little information that was given in the note. If you have yogurt, you are giving yogurt, you all like to take yogurt. If you look at yogurt, you compare it with salad, you're going to see that yogurt is homogeneous in nature. All of them look the same, but we still know that yogurt is a mixture and not a compound. Whereas your, what is it called? Heterogeneous mixtures will not be the same. And you can see some of the indicators that will tell you if you have homogeneous or heterogeneous mixtures are that you're going to see that the composition are the same throughout. You will not be able to distinguish them, and they may or may not scatter light. Yogurt is an example, and you have heterogeneous mixtures. They also have known properties. Example, fruit salad, vegetable soup, and the rest of them. Now, we come to the fourth type of matter. I'm very sure in your secondary school, you've only been, most of you only have information about the first three states of matter, but that in addition to the first three states, you have the fourth one that is known as plasma. And so you're going to see in the slides that I'm going to send to you detailed information about plasma. And they are found in flames and lightning. And you can see plasma are the most common state of matter in the universe. But most of us don't know until now. The sun is an example of a star in its plasma state. So we are used to solid, liquid, and gas. We've learned how to use them, but in 1879, and this is another thing I want you to note, we are going to put some of these names. William Crookes, identify what we are going to ask you, since the questions we are giving you in the exam and the test are going to be MCQ. So you must note some of these names and know the year and some of their contributions to chemistry and science as a whole. So the temperature, you must have seen it in one of the slides where we have the four states of matter. And you know the temperature is higher than 1,000 or 10,000. I can't remember that now. So please just go through the slides and try as much as possible to understand some of the information in it. Now, you can see the difference between plasma. You should be able to note the difference between plasma and gas. Plasma has free moving electrons. So when you heat gases, they turn to ions. And that is when they turn to plasma. And so plasma has that free moving electrons. And you know what I mean? Atoms that have lost, if you have, for instance, sodium, and you heat it, it's going to form sodium ion, which implies that it has lost an electron from 281 to 28. So at this stage, it has turned to plasma. And so I will always talk about ionization energy. The energy is needed to strip off electrons from atom to make it plasma. And so for you to strip off one electron from here to have this, then you must have supplied enough energy. And energy that you supply can be of various origin. It can be thermal, electrical, or UV, or even intense visible light from a laser. And if you don't supply enough energy to remove that electron, then it's going to go back to form that neutral atom. So if you don't supply enough energy, it's going to go back to form neutral sodium if you are using this example. So it's going to go back. So you need to supply enough energy for you to be able to, to do that. So, and because plasma can be accelerated and steered by electric and magnetic, since they contain ions, they can generate electric and magnetic fields. And as a result of that, they've been able to use them to do a lot of things. Some of the things that they use them to do, you're going to see in the slides. As a result of the as a result of plasma, we now have new manufacturing techniques, new consumer products, and we have prospects for abundant energy. But the problem with us in this part of the world is that we've not been harnessing some of the opportunities that we'll see that science has created for us, like the use of this Zoom for lectures. Some of us don't want to imbibe the culture. And you can see, I'm sitting in my office. If we have good network, you will be able to enjoy your lectures without any stress, and I'll be able to deliver the lecture without any stress as well. But the problem is enormous, and we are hoping and praying that in no distance time, most of these problems will be solved for us. So some of the properties like you have for gases, solid, and liquid, some of the characteristics for like plasma, it doesn't have definite shape and no definite volume like gases. And the electrons are not bound. Consequently, we have inter-ionic interactions between the charged particles, and this can self-generate magnetic and electric field. So you must know all this. So they conduct electricity, and some of the effects of plasma are some of the things that you can see here now. Computer chips and integrated circuits, printing on plastic food containers, computer hard drives, electronics, high efficiency windows. These are some of the things that we obtained from plasma. So a lot of things, like the pair of glasses I'm using at the moment is coated with anti-scratch and anti-scratch and anti-glare to enable a lot of additional uh, features on the pair of glasses. So I'm sorry if we've not given the expected chart today as a result of as a result of as a result of what is the problem? So, except you have questions now, maybe I can just, if you have questions, let's see. We are just seeing you, sir. It's better now. Okay. Sorry about that. I don't know if we have this big challenge here now. For some of us that don't know how to use this platform very well, I don't know how they will be able to cope. But I would try to look at the setting again to see if I can help them to prepare for you very well. Some of the teaching problems that I have observed, I will try to resolve it for them before the next person will come online. And I will also, maybe what is going to also happen is that rather than the lecturer finding it difficult to log in if he or she has been logged out, maybe I will do it, the setting in such a way that once the lecturer is logged out, all of us will be logged out. Then once the lecturer log in, all of you will now try to log in again. I think that's the best options for us. Yes, is there any other thing for now? I can say this is what we don't want. Samuel sending, we don't want that. We are serious people here. We are serious minded, and we should do something that is more. Sir, how can we mark attendance? Don't bother, just send. You don't need to mark any attendance. All you just need to do is if you are able to log in, send your information. And that was why I said all we want you to do is just put your matric number and today I can tell you those on YouTube, I can see most of them have been able to put in their details. So there is a question, can ordinary what now? Can ordinary solid and gas change to gas? It's only gas that can change to plasma because it has gotten to a state. But if you have a solid and you heat it, yes. But that solid will now turn to gas before it can now turn to plasma. Yes. Yeah, that question is relevant. Yes, thank you. Can we also say plasma is the smallest part of an atom? No, we are not looking at structure now. We are not looking at structure. We are only looking at types of matter. We're the next lecturer that will come in now will now look at atomic structure, and she will discuss history of atomic structure with you, and that will now enable her to link the structure of atomic it will enable you to link atomic structure from that is mode of atomic structure to the new electronic configuration that we have. For instance, in the Dalton's atomic structure, if I want to write electronic configuration of sodium, I'll just write 281. But by the time you now understand the history, what the history of atomic structure, you now see how they discovered proton, neutron, and electron, consequently disproving Dalton's theory that says atom is the smallest indivisible particles. So with that, we'll be able to understand, and we'll now see, because when you look at 281, you see that for 8, where you have the orbit, where you have 8 electrons, you're going to see that orbit, you are saying for the 8 electrons you have in that orbit, the 8 electrons are equal. But by the time you now introduce 1s2, 2s2, you see that the 8 electrons in the second orbit are not the same. And so we have been able to use that to explain a lot of things. Guys, I'm sorry, the teething problem, we hope to resolve it so that by the time the next lecturer comes in, we'll be able to have better Zoom discussion than what we've had. The first one on Monday, after I tried to disable everything because of the noise, I didn't know by that time I also disabled the uh, uh, lecture slides that I was sharing, and consequently it affected. So you only saw that you didn't see anything except that the audio was the only thing. You were able to just listen to the audio of the lecturer. But as it is today now, we are able to, you are able to see the lecturer, and at the same time, it was possible for you to also hear the lecturer. And it was also possible to live stream the lecture on YouTube. I can tell you it's also possible. What is gas to plasma process called? Ionization. Sir, can plasma be found on the moon? Go and find out yourself. All you just need to do now, if there's any question that is not too clear now, I will send the slides to you, and I will just enjoy you now to go and find more information. Let me also tell you, most of the things we'll be discussing with you, you're going to see in any chemistry general textbook. And we have many of them in the library. You also have many of them online. All you just need to do is to look for general chemistry textbooks, and most of the things we've discussed or we'll be discussing, you're going to see them. But you also need to know why you probably be looking for one textbook. Some of us do combine like 3-4 textbooks. And by the time we do that, we bring out the information from them. I'm sorry if the work has not been done the way you wanted. Is because of some of the challenges that we have. And teaching large classes is always a difficult thing. But with the slides that we have and some of the audios that we're going to send across to you, I believe it will get you prepared for our lectures. Please try as much as possible to attend our lectures. Where you miss the lectures, look for the video on YouTube and try to listen to it. And also look for the lecture notes. We're also going to let you know when we're going to have test. The test, because of the population, is going to be online. So the question of I don't have an Android phone should not arise. Make sure you get yourself an Android phone that will enable you to write our test. For the, except if the CITS can provide a platform for us, which is always difficult. And that's the reason why we are going to go online to take care of the test problem. So thank you for your time. If there are other questions that you want to ask, you can send them to me via WhatsApp through your class reps, or better still, just form discussion groups and try to discuss most of the problems with your classmates. Thank you for your time. So by Monday, another lecturer will come in. So if you don't like my lecture, I can assure you, you're going to see some of the lecturers that you're going to like their lectures. And at the end of the day, you're going to be happy with yourself. Thank you. I'm going to send the slides. Thank you for your time. I'm also the course coordinator. So if there are problems, let me know so that I can try to address them. Take good care of yourself, guys. Enjoy the rest of the day. Bye for now.